Okay, so this video is going to start on page 8. So we'll do pages 8 through 10 on this one. So we're going to start by labeling a wave. Okay, so parts of a wave is our first one is going to be at the top of a wave. That is called a crest. Okay, so this is in the positive direction. Okay, at the bottom of a wave, this is called a trough. This is in the negative direction. The way I remember this is, if you've ever been on a farm, okay, a trough is basically where you dump food into where they can eat or drink. So this whole bottom part looks like, so this whole bottom part right here looks like a trough that you could dump food into. So that might be able to help you out there. Okay, then you have amplitude. Okay, so amplitude is the height, okay, either from the middle to the top or the middle to the bottom. Okay, it's not both of those added up together. It's just the distance from the midpoint to the height, to the top, to the crest, or to the trough. Okay, which brings us to our next one, which is called the origin. Okay, that is the midpoint, basically. So that's how you determine amplitude. It's from the origin to the top or bottom of a wave. And a wavelength is one full wave. Okay, so wavelength is characterized by the upside down Y. That's called lambda. So if you ever see me write that in future videos, that is what I'm talking about, is wavelength. Now, in order to be one full wavelength, so one full wavelength, is you have to have one full crest, so one full up, and one full down, so one full trough. Now, there could be multiple wavelengths. You could go from a trough to a trough. You could do crest to crest, like I already showed you. Okay, or you could even go from this point here to this point here, as long as you start and end in the same spot. Okay, and you have one full crest and one full trough. Okay, that would be a full wavelength. Okay, so moving on to the next part is label the parts of this spring. Okay, so this is a compression or a longitudinal wave. Okay, so where the spring actually bunches up next to each other, that is called a compression. Okay, and where it actually stretches out, okay, that is called a rarefaction. Okay, so a wavelength for a compression wave has to have one full compression and one full rarefaction. So as long as you start and end in the same spot, so I'm going to start in the middle of that compression, and I'm going to go all the way to the middle of that next compression. Okay, so your wavelength has to be one full compression, okay, and one full rarefaction. Okay, a couple other terms we need to kind of talk about is you have period, okay, which is characterized by the capital T. We've already kind of seen that in circular motion. That is the time for one complete wave. And our equation for that would be the T equals 1 over F, and F being frequency. So frequency is our next term. Okay, that's characterized by the lowercase f. That is the number of waves, okay, in 1 second. Okay, the equation for that is F equals 1 over T. So they are inverse of each other. So if one goes up, the other one has to go down. Okay, so moving on to the next part. So we're going to be labeling this wave. So this one, okay, this top one, this is a compressional wave or a longitudinal wave. Okay, so where you see the light parts, that is where there's not many particles actually there. Okay, so this is going to be a rarefaction. So this little light part is a rarefaction. And where it is dark, okay, that is where they compress, so there's more particles there, so that is called a compression. Okay, and a full wavelength is basically as long as you start and end in the same spot. So if I go from a rarefaction to a rarefaction, or I can go from a compression to a compression, those would both be considered wavelengths. Okay, so this would be longitudinal. Okay, and now this next wave right below it, this is called a transverse wave, which we've already kind of discussed. Okay, so as far as wavelengths go, as long as you start and end in the same spot, so you could go from a trough to a trough. Okay, you could go from a crest to a crest. Or you could go from the middle. Okay, so you can go middle. Okay, to the next part, as long as you start and end in the same spot. Okay, so the number one error we see is people that start here, and all they do is just go to there. Okay, so all you had was one trough. That is, now technically you're at the same origin point, but you only had the down part of a wave. You never even went up. So that would actually be half of wavelength. So just be careful with that. Okay, so number one, it says which is a transverse wave. So we just did that. Which is longitudinal. We just did that. On the longitudinal, label the compression rarefaction. Already did that. Okay, number three, what is the wavelength? Okay, so wavelength is the distance a wave travels during a period of time. Okay, so that is technically what a wavelength is. Okay, what is one wavelength equal to in a transverse wave? Okay, so that is, so transverse, one full crest and one full trough. On a longitudinal, okay, that is one full compression, okay, and one full rarefaction. Okay, number four, how many cycles / vibrations are there in one wavelength? Okay, a cycle is a wave, so there is only one wave in a actual wavelength. Okay, number five, what is the amplitude? So we kind of talked about that. That is the height of a wave. Okay, from the origin. So origin was that middle point. So if I were to draw basically a line right here, there's my origin, and my wave looks like this. Okay, that amplitude can either be from the top to the bottom. I'm sorry, top to the middle point, or it can be midpoint to the bottom. Either one will work. So either one of those are amplitudes. Now frequency, that is the number of waves in 1 second. Okay, so the unit for frequency is actually called, so the unit's called hertz. Okay, and it's abbreviated Hz. Okay, and we'll use that a lot more in the upcoming problems. So what is the period of a wave? Okay, that is the time it takes for one full wave. So time for one full wave. And the unit for that would be seconds. 8, what is the relationship between the period of a wave and its frequency? They are inverse. Okay, so because if you look at the equation, so time would be 1 over frequency, and frequency would be 1 over time. Okay, so they are inverse of each other, so that means if one goes up, the other one has to go down, or vice versa. And then number 9, draw a transverse wave and label the amplitude, wavelength, crest, and trough. Okay, so I'm just going to draw a wave. Doesn't have to be perfect. Okay, so my amplitude is, it can be the height from the top to the midpoint, okay, or midpoint to the bottom, the trough. Okay, so remember, so the top point, that is called your crest, and the bottom point is called your trough. Okay, wavelength can be as long as you starting in the same spot. So I keep saying that over and over again, but there always ends up being errors every year. Okay, so if you're going to start from a midpoint, okay, like right here, okay, you need to have one full trough and one full crest. So it goes all the way to there. Okay, so that would be a wavelength there. Okay, or you could go top to top. You go crest to crest. That would be a wavelength. Or you can go trough to trough. As long as you start and end at the same point, and you have one full up and one full down, then you're good. All right, so that'll end that video.